So my name is Trilochan Purial. I'm part of the software engineering. This is my second last semester. I got one more class to finish, and then I'm done. And so, huge thanks to everyone and the professor to letting us do work on this project. And it's a lot of learning and a lot of knowledge. So, Omkar.
Yep. So my name is Omkar, and I belong to cybersecurity major. This is my last trimester as well, this university, and I'm happy to be part of this project and working with my colleagues, and we are happy to get completed this project as well, like together teamwork. Yeah, Annie.
Hello everyone, my name is Hui Yu and you can call me Annie. I am from the Master Program of Engineering Management, and I am so glad to have the opportunity to in this class and working with my two team members. Yeah. So we can start from here. So yeah, I will talk about the first part. First of all, I will give some background and the introduction of our project and our product. First, we all know that in this project, we will talk about voice learner and speech recognition, which is designed by ourselves. It is just a software product at this stage. Yeah. First, I will give you guys some introduction of what is voice learner and speech recognition. We can see here that voice learner is a software agent that can interpret human speech and respond by synthesizing speech. And speech recognition is combined with computer science and computational linguistics that develops methodologies and technology that enable the recognition and translation of spoken language, different kinds of language into text by computers. And from the technology perspective, speech recognition and voice learner has a long history with several waves of major innovations. Most recently, the field has benefited from advances in deep learning and big data technology. As of 2017, the functions and use of voice learners are rapidly expanding. New products are entering the market, and there is a strong focus on email and voice user interfaces. We can see many giant companies all have their own this kind of products. For example, Apple and Google have huge user bases on smartphones. Microsoft has a large number of Windows-based personal computers, smartphones, and smart speakers. And Amazon has a large base of smart speaker installations. As we all know,
next screen, okay? Sorry.
Okay. As we all know, the AI-powered voice learners are efficiently transforming the world with its abilities in conducting natural language processing. Yeah. So we believe that this product, this field, has a very promising and bright future. Okay. Next page, please. Okay. Yeah. Here I will give some brief introduction to our product, which is called Voice Learner. Our Voice Learner is a computer software program with the ability to decode the human voice. It is commonly used to operate a device, perform commands, or write without having to use the keyboard, mouse, or press any buttons. This is done on computer with an automatic speech recognition software program. Yeah, it requires the users to train this program first to recognize their different users' voices so that it can more accurately convert the speech to text. For example, you could say open internet, and the computer the computer would open the internet browser. Here I also give some detailed examples of where you might have used our voice recognition. The first one is about.
Sorry.
Yeah, back to the. Yes, yeah. The first one is about automated phone systems. If you have ever been asked something like say or press number 2 for support, and you say 2, you will use the voice recognition to call. And about digital assistant, the users can use voice recognition to interact with digital assistants that help answer questions. And also in terms of car Bluetooth, for car users with Bluetooth or hands-free phone pairing, you can use voice recognition to make comments such as call my husband to make calls without taking your eyes off the road. Okay, next page, please. Yeah, and in this slide, I will talk about some market analysis things about our industry. We can see that, we can see that the digital experience supported by the voice learner is considered one of the major trend in our current times. Yeah, so by mid 2017, the number of people using digital voice learners worldwide is estimated to be about 1 billion, so a very big market. And it can be observed that the voice learner technology is no longer a graduate smartphone application, and it is now used in many different other industries, including automotive, telecommunications, retail, healthcare, and education. Due to the large research and development expenses and humans and intelligence in this industry, we are expecting that the voice learner technology market will grow at a global compound annual rate of 35% between 2016 and 2024. Yeah, so very promising. Also, its scale will reach $7.5 billion. Yeah, and due to the promising future of this market, there are dozens of similar products. Yeah, so here I list a table to compare our products with other similar notable ones. Yeah, we can see in this table that yeah, here I list several famous ones, including Alexa, Alice, and Assistant, Google Assistant, yeah, these kind of things. And most of these products are not providing free software and also without open source hardware. Yeah, so the technology part is still a challenge for all of us. And we can also see that most of the similar voice learner products are involving with IoT, and all of the voice learner programs can be downloaded and used in smartphone app. So this is also what we will have in our product. So compared with these notable ones, why will our voice learners be outstanding? We decided to develop our product as a high cost performance ones. We decided to provide a cheaper product while not sacrificing its functions. And also, we all know that some famous ones like Alexa and Google Assistant, they can interact with people with relatively complex questions and answers, but our product will provide short and clear responses. Basically, the best answer the users can get through our product, which will be more efficient. And at the last of my part, I will talk about our business model. I use the business model canvas and draw a picture to show our business model. First, we can see who are our key partners. I list electronic hardware device providers like Apple, Samsung, Huawei, and also software service providers including Amazon, Google, Facebook, TikTok. all of them could be our key partners. And as for the key activities, we will create an efficient supply chain to increase user volume, which is closely related to our key partners. And we believe that our key resources are the high cost performance, which means cheaper product with more efficient ones. Yeah. And as for our value propositions, we believe we will provide key technology and low cost. As for the customer relationships part, here I list 3 kinds of relations: self-service, automated services, and communities. All of these 3 customer relationships will cut down our cost in this part. And as for the channels, we will use our own channels like storefront and also partner channels, as I mentioned in the key partners part. And we will also combine both of them. As for who will be our target customers, I choose 3 customer segments here, which is mass market, diversity, and a multi-sided platform market, which means our product will be widely used to different segments of customers. As for the cost structure part, our fixed costs will be the unchanged ones across different applications, like our salary to our staffs and our rent money. The variable cost will be depending on the amount of production of goods and services, like how many devices or software services will buy our product, and also economics of scales and economics of scope, like our mergers and acquisitions. And as for our revenue streams, I believe our revenue will come from a set tier, usage fee, subscription fees, lending, leasing, and renting fees, and also licensing fees. Okay, thank you. I have finished my part.
Okay.
Okay, thank you for that analysis, Annie. So yeah, next slide, Trilushan. Yeah. So I'll be talking shortly on how do we develop our product from day one. So that's basically can be accomplished based upon the few points. The first very important, which we believed in, is teamwork. We need to cooperate and within our team to complete the project on time. We can also do like a market-based analysis, because we have to distribute our work within our team, and so that we can meet our set deadlines. During the span of this 2 to 3 months, we divided our work and we did our analysis on our own, and then we jotted down few points, what to work on, and what's currently there out in the market, and how we can improve on that. So here the critical thinking ability comes in. All of three of us come from a different background, so that proved to be beneficial. We have diversity of skill set, so that helped a lot, because Trilushan is good at some points, Anna is good at some points, so that's how the team builds, and then we were finally able to complete our project on time. So the commitment, right? Our focus for this is most important. Satisfying user needs. So we need to think from the user's point of view. When the product is launched into the market, how it would be impacted, like how the users will be impacted by that, or how flexibility it can provide to the users. So we had to think from the user's point of view what their experience would be. So we did some pre-launch rigorous testing for that. so our project like is divided into like a market analysis, testing phase, and then the code validation part. We had to make sure like there are no errors reported. So that was all done in testing. Next slide, please. So how did we launch a product? Like how to launch a product? So we need to make sure like we need to understand our customer needs. As I said before, we need to take our user interaction, user flexibility, their point of view into consideration. And so that's how we can launch our product or market our product efficiently. We need to have a good pitch in front of stakeholders. We need to make a stand in the market that our product is efficient and it can definitely prove to be beneficial. And we need to planning, right? Like the planning is also considered to be an important strategy when we decide to launch anything or build upon. So effective planning is important. And then setting of goals, having a clear vision. So all of these points like come into picture later on when we try to go on like a go market strategy, and consistently being in touch with our team members and just motivating them, like having a positive mindset, that helps a lot. Next is milestones. So this is how we were able to execute and complete our project. First, we had an idea on the day one when we started 3 months ago. We had an idea in mind, and so all three of us decided on that idea and to work on, and we were happy with that, and so we decided to work on this project. Next phase was the market analysis. We need to know our competitors, who they are, and what their product is, or what the user feedback is currently for all of those products, and what is lacking in those products. So we need to do some market analysis, and what we need to work on. We made use of so our product is based on the Python code. So we tried to do our execute our product like using Python code, using the Google Assistant package, which is currently available for the speech recognition software. And then we completed the testing phase, which ran successfully. It did not reported any errors. But we wanted to execute our product with the Python code using TensorFlow. So we started working on that in the second month or so. So this was a part of again effective planning, and this was completed. We did the testing, and then the final design approval was decided between us, and we also worked with and the product completion, basically the product completion phase. Next slide.
All right.
So my colleague Trilotion will be following up more on these topics.
All right, thank you, Omkar. Hey everyone, this is Trilotion again. Let me dive a little deeper on this project that we did. Basically, it's derived through AI, artificial intelligence, machine learning. First thing when you do some kind of machine learning and try to create a product, what involved is 5 points, right? The basic, gather data, whatever data you need, because you need to teach AI, what you want to accomplish, right? And the next thing is your data is dirty. There are a lot of things involved. You need to make sure your data is all good. You have to pre-process that data. That takes a lot of work, and it takes a lot of work and it takes time consuming. Third is once you have data, once you gather the data and process the data, you want to find the best model to teach, to input your data and teach the model, right? What kind of model? There are a bunch of models that are in the market. You want to find out which model works for your product, and that's one of the decisions we have to make. And after that, once you decide on the model, the fourth one would be you train that model and test the model whether you are getting whatever your target is, and you want to evaluate at the end, you want to do the evaluation of the product, right? So those are the 5 points. So what are we doing right now, right? So basically, we have built AI kind of assistant where it can, it'll understand your voice and then, and give you a feedback, right? Whether, it's basically learning, it's a machine learning. It'll learn from you. You teach the machine and it understand what you're saying, basically. So for that, the biggest challenge we had was like, where do we get the data, right? You have to teach the machine. You can't give a 5 voices and then teach it because it doesn't understand. It needs a lot of data. It needs a lot of time. For that, thanks to Google, they have 65,000 of data, which is a voice recorded in a different, so basically they have different words right now, and they're like 65,000, and they're recorded by different people with a different accent so that you can teach your machine so that it understands later, right? That's where we started with data. So basically, yeah, that's the same thing again. So basically, if you look at the data here, right, you have the right word right, 8, cat, tree, you have like 3,500 were right. You have like, if you talk about the word 9, you have like around 35, almost 4,000 words. If you talk about like the word visual, you have like around like what, 1,500, 2,000. So these many data, we have to give it to machine and it has a lot, right? That's a lot of data. So for that, what are the tools that we use, right? Obviously Tensorflow, that's one, and LibRusha, that's another the Python library to process the data or get the MFCC and JSON, NumPy, MATLAB to plot it, bunch of stuff, right? So if you want to talk about TensorFlow, it's it's open source from Google, obviously. It's a machine learning platform. It's flexible, it's a community, resources, and it supports Python, right? And then, it's Python easy to learn. So that's one of the reasons TensorFlow, and it's one of the best platform in the market. So we use LibRusha to process the data. It's a Python package again. It's mainly used for music and audio analysis. So one of the things we need is the MFFC coefficient to analyze the audio signal and then input that signal to the data model. So other is NumPy, sklearn. That's one of the part of the TensorFlow. It's a library for Python programming, obviously. Which is, and it's classified. It's really good. Yeah, this is one of the package we use again, and then matplot to plot the graph. All right, so we have our model, and then there is a model from the TensorFlow. So what TensorFlow says is you pre-process the data, you build the model, and train evaluate. That's what we're doing right now, right? So why TensorFlow? It's open source machine learning framework. So if you build something in TensorFlow, it can be run anywhere. It will run on your local machine. Maybe it's hard because you might not have the computing power, but you can still run it. You can run in the cloud, and you can run in any devices. So that's really good. It's Python friendly. It's Python is easy to learn. I think one of the focus we did on this project was to learn Python and learn machine learning. I think we kind of did that one, so that's good. And then TensorFlow can train and run, CNN deep neural networks, right? So I don't want to go through this again. I think we talked about data processing. You process the data, and then you just basically I want to talk about MFCC, male frequency cepstral coefficient. This is part of the signal in audio. So basically, what you're trying to do is you're trying to identify the component of the audio signal that are good for machine learning, right? And then you discover a bunch about the noise, and then you use that to give it to the model, right? So that's what I've been. So when you look at the raw wave of one of the the command or one of the voice you have, this is what it looks like, right? In time, so this is time, and this is the amplitude. This is what it looks like, right? And this is what we are interested in. So when you say pre-processing the data, it means we're trying to extract MFCC. So this is one of the important feature, right, of the machine learning of data, speech recognition, right? What you're trying to do is you're trying to extract the MFCC, which is a signal or a small set of features, usually about 10 to 20 megahertz, I think, which describe overall shape of the spectrum envelope. It describes about the signal of the sound or the voice, right? This is what you like when you plot one of the voice, right? Then comes second part. What are you going to do with the model? What kind of model are you going to use? So we're going to use CNN model, convolutional neural network, right? So that's one of the models we'll be using it to make the machine to learn. So this is what it looks like. So you give the voice, right? You have audio, you talk to the machine, right? With the various action, whatever action you have, and then there's a CNN model and then you feed to the CNN model, and then at the end, what you try to do is it will try to predict whatever you said from after the learning, right? So this is what our architecture. So MFCC input, basically that's the extraction of the signal from the audio, and you have the CNN model. You have convolutional layer 1, layer 2, layer 3, and there's a bunch of other stuff involved. And then you once you have that one, you get the output as a prediction, right? So you load the data, build the CNN model, train the model, and you evaluate, make sure that it understands, it learn whatever data you get, right? So training and testing model. So this was pretty time consuming, I think. So teaching that like 65,000 a word took around 3 to 4 hours. And then one of the issues was because of computing power that we had. So I'm running, right now I'm running on my local machine, which is 1.6 gigahertz with a dual core, right? With a 8 gig of memory. That wasn't enough. So basically, it took a lot of time. So what you're seeing right now is an accuracy evaluation, right? So basically what you want to see is they align closely. You have the raw data, and then you have the accuracy once you train the data, right? They are like parallel, that means it's learning good. And then when you look at the data, once you train everything, so its test accuracies are 89%, that means it's good. So if you have like less than 60%, that is not that good, that means it doesn't learn much, right? And then you can always you can always improve the thing, improve it with a lot of adding more layers, and then working on other patching, all this stuff. But you want to make sure you learn test accuracy more, right? This is okay. So let me do a quick demo, right? I think that will give us what.
We have a quick and short demo to illustrate.
Yeah. Give me a second, please. So I can do a live demo, but I thought I did record it already a little bit earlier, and then maybe sometime when you try to do live demo, sometimes things doesn't go with the internet and everything being online. So I did record it earlier, and I'm gonna play that one. Okay. All right, let me
try to wrap up on the demo. We can always get you back to do a demo later. Just do it in like 5 minutes max.
Yeah, this is a quick demo, Professor.
Yeah, done in 3 minutes. Right.
Okay, because we need 10 minutes for questions.
Sure.
Okay, I'm gonna play my demo.
That was trained by the model.
Marvin.
Checking now. I am able to predict your spoken voice, Marvin. Please say a word that was trained by the model.
Sheila.
Checking now. I am able to predict your spoken voice, Sheila. Please say a word that was trained by the model.
Happy.
Checking now. I am able to predict your spoken voice, Happy. Please say a word that was trained by the model.
House.
Checking now. I am able to predict your spoken voice, House. Please say a word that was trained by the model.
Cat.
Checking now. I am able to predict your spoken voice, Cat. Please say a word that was trained by the model.
Down.
Checking now. I am able to predict your spoken voice, Down. Please say a word that was trained by the model.
Forward.
Checking now. I am able to predict your spoken voice, Forward. Please say word that was trained by the model.
Off.
Checking now. I am able to predict your spoken voice. Off. Please say word that was trained by the model.
Visual.
Sorry, Visio is either not trained or I do not understand what you said. My apologies. Please say word that was trained by the model.
Stop.
Checking now. I am able to predict your spoken voice. Stop. Please say word that was trained by the model.
6.
Sorry, 6 is either not trained or I do not understand what you said. My apologies. Please say word that was trained by the model.
Coffee.
Sorry, coffee is either not trained or I do not understand what you said. My apologies. Please say word that was trained by the model.
Exit.
Please check the accuracy % on the console. Thank you for using Voice Learner.
All right. So what happened here is, so I try to, I gave the machine 12 voice, right? 12. I tried to, I spoke 12 voice. It understood 75% of the time, 25% it didn't understand. It didn't understand 2. It didn't understand 6. It didn't understand visual. And I said coffee because coffee was never trained. It's not in the list, and it didn't understand, right? Basically, that means I have an action, and and if you have a, so basically it learned good, right? It machine learned good, and it understand my action, and it was able to give me the correct prediction. That means we can take this model, put it in everywhere, like in a search engine or a mobile phone or a mobile application, anywhere, and use it, and it can understand it already run those world, and you can use it anywhere. I think that's the thing. So yeah, that's all. Yeah, I think that's all. Machine learning, and then it's learning by itself, and we can give more data and make it like right now it's learning 30 words. I think we can make it more. Yeah, that's it. Thank you, everyone.
Thank you so much. This was.
Yeah. So the conclusion here is it's about the accuracy. The accuracy is greater, higher as we predicted, and that's the results that we are able to see over here.